In this video, we are going to cover the shadow formation. When an opaque object is lightened, some areas located behind the object don't receive light and form the shadow of the object. Here we have a point light source. We take two limit rays, one to the upper side of the object and the second to the lower side of the object. In this area, no light reach here, so we have an umbra where none of the light is reached, and this area is lightened. So I have one shadow. If the light source is big, so we take 2 points, and these points behave as a limiting light sources. And again, as in the point light sources, we take 2 limiting rays, one to the top of the object, 2 to the bottom of the object, and from the second light source, 1 to the top and 1 to the bottom of the object. Here you see that this area, none of the lights reach, so we have umbra. In umbra there is no light reaching, and we have at the outer circle some of the light reached and some didn't, which we call penumbra. In order to find the dimension of the shadow formed, we use the similarity of triangles. Now here you see that the triangle OAB is similar to the triangle OCD. So the ratio of AB to CD, which is equal to the radius of the object to the radius of the shadow, is equal to OB to OD, which is equal to the distance of object to the light source over the distance of the shadow to the light source. So as the object gets closer to the light source, the shadow gets bigger. As the light source gets closer to the object, again the shadow gets bigger. As the screen gets closer to the object, the shadow gets smaller. Solar and lunar eclipses are the examples to shadow formation. During a solar eclipse, the shadow of the moon passes over the surface of the earth. The moon is between the sun and the earth, and as sun is a huge light source, you see that we take 2 points and take the lights to the top and bottom of the moon. So here we get an umbra and penumbra formed on the earth. In lunar eclipse, the earth is between the sun and the moon, so earth's shadow is on the moon. As moon is so small, we get the other light rays. Here we have umbra and the moon is in umbra, so cannot be seen. Which one is how the observer at point O sees the object M? The eye can see from K to L, but the light rays just reached here. So this is not light rich, so will be observed dark. So what the eye will observe will will be like in C. Now this part is important. We are going to match the given shadows with the suitable observers K, L, M, N, and P. Now let's begin with N. The N, draw rays to the top and the bottom of the object, and these are the regions where no light reach to N, so it will be seen as dark, and the other lightened, so it will belong to N. But in K, again we draw to the bottom and top of the object, so these are the areas that cannot be observed by K, so D will be the shadow observed from the point K. Now let's do with M. Again we draw rays to the top and the bottom of the Y, so there will be at the center a region where no light reach to M, so M will observed as C. Now let's draw for L. We draw light rays from the top and bottom of the object, so these are the areas which cannot be observed by L, so it will belong to A. And the last one, P. Again I draw one to the bottom, one to the top, so these are the areas that cannot be observed by P, which belongs to the picture in B. Which one is the shadow formed on the screen? We have point light sources, so I take two rays to the top and bottom of the object, so these are the areas that no light reach from the first light source. Now do the same for the second one, so one to the bottom, one to the top, so these are the areas that no light reach from the second light source. So the intersection point here is the area where no light is reached, so here formed umbra, and these are penumbra because some reached and some didn't, so it will be observed as in A. A student stands in front of a white wall in a room that's dark except for the light from two small light bulbs, one red and other green. In the top view at right, 4 locations A to D are labeled. Determine the color of the wall at the label points. Now we are going to think of the man as an opaque object, so take two limiting rays from the side of the student and do the same for the green light. Now you see that these areas are the parts that only red are reached and no red here, and for the green one, these are the areas that the green and are reached and no green here. So when you look at to A, it will be red plus green, which will be observed as yellow. In B, only red reach, so B will be observed as red. In C, no light reach, so it will be observed as black. And in D, only green reached, so it will be observed as green. Now let's talk about pinhole camera. It's a simple device which helps to understand about the rectilinear propagation of light. Now we have a box and there's a pinhole in front of the box that the light can reach only through this. So I have a lightning object, so I take 1 point from the top and 1 from the bottom. Think of them as point light source. So there are many lights coming from the top, but only this can go through the pinhole. So the light will have the image here as X prime. And why only this directed ray can pass through the pinhole? So it will be lightened here. So you see that you have an inverted image. So from the similarity of the triangles, this triangle is similar to this triangle. So the height of object to height of image is directly proportional to the distance of the object to the distance of the image. This ratio gives us the magnification of the pinhole. What's the property of image of the candle fire on the opposite side of the screen of hole K? This is hole. So I put 2 limiting point sources to the top and the bottom of the flame. This light will go through the pinhole and will be lightened here. Let's say A, it will be lightened A prime, and this point B, only this directed ray will go through the hole, so it will be lightened here B prime. So I will have a candle lightening on the screen like this. So let's find the height of the image. Let's say the height of the flame is h. So from the similarity of this triangle to this triangle, the height of object or the height of image should be equal to the distance of flame to the hole over the distance of image to the hole. So the height of the image will be 2 times the height of the real flame.